Everyone. I hope you are all well and safe and working in your classes, ready for this semester to be over. And so, if you are, make sure you finish strong, right? So, I'm going to talk to you today about Chapter 12. Chapter 12 is Judging Scientific Theories. We're going to have a little bit of, well, there are 7 sections here, so we're going to be a little head down and running. So, keep up. This is from my PowerPoint, so if you have that handy or not, whatever works for you, that's where I'm working from today. So, 12.1 is science and not science. And so there's 3 crucial sentences, 2 big words, and a partridge in a pear tree. And then we're going to talk about test implications. Okay. So the 3 crucial sentences is about science. Okay. And science seeks to acquire knowledge and understanding of reality and does so through the formulation, testing, and evaluation of theories. When this kind of search for answers is both systematic and careful, science is being done. Science is not technology, science is not ideology, and science is not scientism. Theories generally reach beyond the known data to posit the existence of things unknown. And that should be page 424, not 421. Okay, I'm making changes on here and then I'll make them on your copy and fix it on the class Blackboard page or whatever page. Okay, the scientific method is 12.2. And there are 2 big words. Okay, science and scientific method are both big words in our last test. Science is not in the glossary, okay, but it is in the chapter. And when we're looking at this is the one I want you to use on page 423. Science is an extremely reliable way of acquiring knowledge about the empirical world. That's on page 423. The scientific method is 5 steps to determine whether or not we should accept a theory. Okay, and so five steps: identify the problem or ask a question, devise a hypothesis to explain the event or phenomenon, derive a test implication or prediction. If it's true, what's going to happen? Okay, that's all a test implication is. Okay, perform the test or observation, accept or reject, or what usually happens, rework the hypothesis. Okay, so a test implication is an indirect test of the hypothesis, usually used when testing directly is not possible or practical. You don't want to kill people, right? Well, not in this case anyway. Imagine testing for the causes of leukemia in humans. We begin with laboratory test stuff in petri dishes, then move to rodent tests because they are more similar to us than we want to admit. Then to trials and experimental treatments, then to mainstream protocols. Okay, so this hypothesis, okay, we cannot say definitively yes or no, right? We're inductive reasoning. So if this hypothesis is correct, then C, this thing will happen. The thing didn't happen, therefore the hypothesis is not correct. This is a modus tollens, so it's valid. So if H, if the hypothesis, then this condition, yay, the condition. Therefore, the hypothesis is kind of correct, except it's not valid, and it's not going to be because we are, doing the inductive thing. Just because C is true, the condition is true, doesn't necessarily follow that the hypothesis is true, but it does give us more reason to believe it is. Okay, adds to our positivity on that one. Okay. When we're talking about testing scientific theories, there are 3 kinds of testing things. Okay, so a clinical test is the direct use of the theory on test subjects, eventually on humans. Okay, observational, tracking a particular population to see what they do or don't have the relative issue. Okay, replication, someone else does your testing in their lab to hopefully get the same results. And this last piece is very crucial to anything that has to do with medicine or human medical stuff. If you can't make it happen every time, then you really don't want to chance saying it out loud, putting it out there in the public, or giving it to people. Okay. Now, the replication part is what makes certain things that folks, the hill they're going to die on kind of thing. Um, Replication is a problem in that if it doesn't happen, okay, and you love this theory is your favorite theory, but you're the only one who can make it happen, then it's problematic for the rest of the world. Okay, so kind of keep that in mind. One of the things that we that the scientific community does and medical community does is what they call non-intervention studies. It's population studies. So we know that people who live in Greece, Italy, Northern Africa, the Mediterranean area, they tend to live longer than those of us over here on the other side of the planet, and they tend to live healthy longer than we do. So why is that? Well, they do these population studies, and they find out that, oh, well, they they don't eat processed food, um, they walk a lot, they you know um, they have close knit families, they have regular, um, like, they go to church on Sunday or Friday or Saturday or whatever their thing is. And so they have good community connections, they have good family ties, they eat the good food, and they walk a lot. And lo and behold, when other people, even outside the Mediterranean area, adopt those practices, they're healthier longer and they live longer. So that's a population study. We didn't go make people do things. We're like, hey, these guys have the highest per capita incident of people who live healthily to be 100 years old. What do they do that we don't? Lots of things. So we go and do things. Yeah, it's helpful. It's not going to cure your cholesterol, but it's helpful. Okay, judging scientific theories, we use the criteria of adequacy, just like we did in the previous chapter. Testability, fruitfulness, scope, simplicity, conservatism. Okay, and he gives us 3 detailed examples to kind of review these processes. Copernicus versus Ptolemy. Excuse me. Everybody used to believe that Earth was the center of the universe. Kind of makes interesting sense, huh? And so the sun revolved around us, all the other planets revolved around us, and Ptolemy said it's concentric circles, basically. You put the Earth in the middle, and then everything else goes out like this. Okay. Well, Copernicus comes along and he says, that doesn't make sense. Look at all these other things you have to do, basically. All the number of assumptions you have to make are huge, and you have to readjust all the time. It doesn't account for what actually happens in real life. It's a nice theory, looks pretty, but it's not what happens. And so he showed basically that we have a heliocentric system, and you have to imagine not having a very good telescope to see out there. Now we have the James Webb telescope, which is awesome and gives us great pictures. But he didn't have those. So Copernicus has the better theory. The sun is the center, because so many things could not be accounted for. And a couple of things that are interesting about Copernicus's theory is that he said, no, it's not concentric circles. There are basically, we're ovals, we're ellipses. They goes out and back and out and back. And different ones have a different track. I mean, obviously, the planets don't run into each other, so there's got to be something that makes everything work together. And so he did a lot more than just say, We're not the center of the earth. He got put in house arrest for that, and eventually, um, yeah, all kinds of interesting things for him. Another thing that we have in there is evolution versus creationism. Can you see evolution? Well, not exactly, but we can see its results. Um, think about the seasonal flu or COVID um, mutations. Um, there are gaps in the fossil record. The sheer number of species makes this likely and reasonable. And actually, in the kind of writ large theory of evolution, there's stuff for that. What about intelligent design? Science says no miracles allowed, but we do allow for leaps of evolution during stressful times. Um, and I think there are lots of ways to reconcile um, creation with evolution. It just depends upon how you read years, kind of thing. Yeah. Anyway, and then climate change, another hot topic that people really don't want to talk about. We need to realize there's a difference between describing what's happening and then what to do about it. Describing what's happening isn't a moral thing. It's okay, this is what's happening. So now what we do about it. And then there's a whole host of possibilities of things that we can do to help limit our production, our enlarge greenhouse gases. Okay. Science and weird theories. Why bother? Really, so we can process the popular theories and assess them carefully. Um, there are lots of weird theories out there, and we're going to talk about a few of them, I think, here in a minute. But in this section, his point is our tendency is to go, doesn't matter. But for lots and lots of people, it's a big deal. And so if we're going to help them think more critically, and if we're going to think more critically, we have to know about these things and why they don't work. Okay. Carl Sagan, different quote than what we had on discussion board. I maintain there is much more wonder in science than in pseudoscience. And in addition to whatever measure this term has any meaning, science has the additional virtue, and it is not an inconsiderable one, of being true. Okay. If you're going to learn something true, basically. Okay. Making weird mistakes. We do this, scientists do this, people do this all the time because we like the rush, right? We like the sensationalism. We like all that. It's why we watch, you know, what do you call it, reality TV and that kind of stuff. Okay, weird mistakes. 4 things that we do, and we're going to talk about each of these in a minute. Leaping to the weirdest theory. Okay, mixing what seems with what is. Logical possibility versus logical impossibility. Physical possibility versus physical impossibility. Those are interesting little tabs. 3 more guys, and then we'll be done with this chapter. Okay, 2 more crucial sentences. 1, just because you can't think of a natural explanation doesn't mean there isn't one. Okay? And just because something seems real doesn't mean it is. Okay? When we're judging weird theories, we're going to use the test formula. Okay? State the theory, check for consistency. That eliminates quite a few. If it's not answering the question we've asked it, and if it's inconsistent in its own self, then we can discard it. If it meets those 2, then we go on to look at the evidence. Okay. And be careful of fallacies. Just because somebody you don't like said it doesn't mean it's untrue. It might be untrue, but it might also be true, so we have to be careful. And then look at the alternative theories, run them through the same couple questions there, and then when you've weeded it down to things that are plausible, test with the criteria of adequacy. Do the testability, fruitfulness, scope, simplicity, conservatism. Make the chart. Okay. And then he gives us a few weird theories. Crop circles. Human or alien made? The short answer is human. There are lots and lots of folks out there who think this is great fun. And they make some beautiful, beautiful pieces. But don't do that. People have enough on their plates right now. Eyewitness testimony and extraordinary things. I know people who have seen what they believe wholeheartedly is a UFO. Um, okay, so what we expect goes a long way to proving what happened. Okay, and so if we're open to the idea that there might be visitors from outer space, um, when we see something that vaguely looks like what we see in the movies, you know, because in large amount, science fiction becomes science fact after a few years. I mean, the idea of cyber anything, okay, cyber um, was a term coined in the 50s. Um, oh, I just lost his name. I think it was Philip Dick. I know, unfortunate name. But anyway, he wrote about the cyber people, Cybermen. And if you're a Doctor Who fan, you know about Cybermen as well. That also came about in the 60s. So it's not a new word, um, but it took a while for it to become real as opposed to fiction. When we're judging weird theories, we have to make sure that we're giving them the same kind of scrutiny we would give other theories, so that we can make sure we're on it. Another one that's interesting is talking with the dead. Psychics and we call them mediums, seances, things like that. Are they real? Depends on who you talk to. Why people believe psychic readings? Most of it is an emotional response, something we want to believe in, something we want to know about. Um, what happened to this person who died, or where is, you know, my mom hid this necklace somewhere. Where is it? Kind of thing. Um, and the long and short of that particular why people believe psychic readings, there's a good little forethought thing there. Um, Language is inherently ambiguous. It was never meant to be precise and um, deductive. We make it fit sometimes in those areas, but language is inherently ambiguous. Things that you say in your mind mean X. In the person you say them to, they might mean X plus 5, or they might mean something totally different. And so it's very important for us to be as precise as we can in our language, but also to realize that there are going to be misunderstandings. There are going to be people who take what you say and twist it against you. Happens. But language is inherently ambiguous. Don't let them get to you. Okay. It's okay. We'll be fine. So chapter 12, judging scientific theories. I hope that helps you a bit. I hope that gives you some um, answers to things that you're working on in the chapter. But if you have questions, you know what to do. You have my email.